Good morning. Buenos días. Dobre утро. Okay, now the date is going to be quite interesting with this amazing topic, big data. The question is, who does not know what big data is? What is big data? Это что? Okay. May you guess what is saying this word, big data, for you? Nothing. Big data. A trap from the president? Yes? Okay. Who can give me a definition of big data, but the person doesn't know what is that? Big data. Who does know what is big data? Who knows that? Yes?
Should I tell in Russian or in English? Big data.
Big data is information that has meaning only in huge volumes. In isolation, it doesn't create as much importance as taken together. She's from Khakassia. I wanted to boast about Khakassia. We have such people in Khakassia.
Okay. The idea of this session is going to be what is big data, where to use big data, how to use it. Is the future or is happening right now? And even better, how it can have the impact on projects. To start my presentation, I am Jaime Yela from Colombia. I have been working for more or less 2 years with the European Parliament. We are doing mostly part of translation, CAT tools, applications. Imagine this, 24 different languages are going to be translated in an efficient way. 3,000 translators from all over Europe. What is doing the Colombian there? As well, I was starting a very nice hobby, that is startups with young people who want to travel all around the world. This is my baby, my startup. And as well, I just give some advices about how to use digital ventures and startups as well all around the world. So it's my pleasure now to start with the people who are going to give us the information. And it's Eric Manens, Professor of Laboratory and Analysis and Data Processing, Data Science Lab, Ghent University. Evgeny Rosinski, Director of Service Technologies, IVI. And Nikolai Pavlushev, Director of Academic Programs in Acronis. Keep your questions because the best questions are going to be selected for a very nice prize. So I hope you enjoy it, and just keep it in mind that surprise at the end for the good ones. Let's start.
Morning, everybody. Okay, every now and then I have to see what slide it will be, but all right. Maestro? Or should I press start? No. I'll dance. All right. Let's make data big again. For me, big data, very simple. If the information is not computable on one computer, it's big data. It's as simple as that. Why don't I see my slides? Technology. All right. So this is me. All right. Warning. Every now and then, I will call you bunkers, or maybe you can call me bunkers, right? We'll see. You see this slide every now and then. It's all about perception. 11 years ago, this little device did not exist yet. Now, 11 years later, on this device, your mobile phone, there's already artificial intelligence on it, Siri, for example, and you can watch live virtual reality in HD on your phone. If I would have told you that 11 years ago, when you were all pretty small, but anyway, you, for the first time, you would have called me bonkers. We would not have believed it, even me, all right? But let's say, in the not so far foreseeable future, a self-driving car will produce 4 terabytes of data every day. 4 terabytes, big data, right? So it has to be mastered in some kind of way, and therefore we will need artificial intelligence. Now also for, I'm already quite old, you see how much data is coming at us. Every 5 years we have to know a new term just to get grasp of all the information out there. And I kid you not, by the time you have kids and you play on your PlayStation 37 or something, learn the term Domjet Grootbyte. Domjet Grootbyte. I kid you not. Who invents these kind of things? Lots of data. So we have to master all this data, this big data. And there's machine intelligence who will help us, right? And now I will give you some technical information on big data and on AI. The first thing is that to do data interpretation, there's plenty of stuff you have to do. First of all, you have to do cleaning, transformation, extraction, acquisition. All these things you have to master and do before you can really learn something of your data. And the most important two are data cleansing and data transformation. If you have a firm that says, I'm going to solve your big data problem and it's going to only take me a week, don't believe them, right? It's the Pareto effect, like software engineering all over again, the 80-20% rule. In software, you write 20% of your time, you test 80% and debug 80%. In big data, it's the same. 80% of your time will be data cleaning and data transformation. Only then the data will be given to your artificial intelligence algorithms. All right. Some very, very quick things on AI methods. So the two most well-known AI methods are supervised machine learning and unsupervised machine learning. So on the left-hand side, you have supervised, which means that, in fact, all the data has to be labeled, right? And on the right-hand side, there, the machines or the algorithms just learn stuff, but the only thing they really can do is, in the end, kind of cluster the information, okay? Now, if you use these together, you kind of use these algorithms in deep neural networks. On the bottom you see, for example, we try to classify images and try to recognize faces, right? So in the first level of neural networks, or the first levels, what you do is you have these unsupervised algorithms that try to find features. First, low-level features, and as we go along deeper in the network, you learn more, and you learn more high-level features. So in the end, if you're at the third level, for example, it could be that you find out faces, but then you do not even know which face it is. So there you need the supervised, so you have to train your stuff or your system with lots and lots and lots of data to really recognize somebody, okay? If you have questions afterwards, you can ask them. Now, why is the hype on big data and AI now? Well, there's 4 reasons why the hype is really now. Oops, so too quickly. Damn, can I go back? Yes. First of all, it's only since a year or 2 that everybody can afford big machines. Only for a few $1,000s or something, you can hire a dedicated machine at Amazon or Google to do AI algorithms. The second one is that also since a year or 2, a lot of tools are freely available to do AI and machine learning. One of the most notable, the Google TensorFlow stack or the Apache open source stack. So even if you're not a mathematician or a computer scientist, well, in 7 lines of code, you could have a deep neural network that has to be trained. Maybe you do not understand these 7 lines of code, but nevertheless, you can deploy a deep learning system yourself if you want to. The other thing, there's lots of data now on the internet that can be used to train these things. And most of all, for you guys, the white raven makes the difference. So if the engineering skills or the ingenuity of an engineer really can make a difference in big data. So keep on learning and studying. Now, I'll give you one example, or one of the most fanciest examples where AI and big data is already used. It's a little movie it used to be an American company, Boston, what's it called? Boston Dynamics, but now it's been, yeah. No. Only you should hear the machine, not the music. Anyway. The thing started up very stupid, right? But it learned as it progressed. So it's full of LiDARs and steer sensors, and it had to learn, keep his equilibrium. It had to learn how to drive, and as you will see, it learns lots of other stuff. There's a state-of-the-art machine learning and artificial intelligence, mostly based on visual sensors, though. I want to see him jump. You see here, of course, it's vastly American military, vastly put a lot of money in it, of course, right? I think it tried this a lot of times before it could do it, or she could do it, all right? Okay. Another one, this is Belgium. This is a project of mine. This is in the city of Antwerp, where we really deployed an end-to-end IoT big data platform where we could measure, analyze, and predict stuff for whatever sensors out there. And we did that together with all the open data of our local, regional, and federal municipalities, right? And well, maybe if you're interested, we also have an open source framework, Tango, where you could deploy big data technologies automatically and very easily. Because what you have to know in big data, to deploy big data technologies, well, you need lots of components, right? And it is very difficult to let all these components work together. But with Tango, it's a matter of minutes. Right? So check it out. It's open source, Tango. Now, should I worry about AI? I guess you would, or I say you should. The adoption rate of technology you see here, for electricity, it took 50 years to be a common good. And you see, the way we go up, it takes less and less years to be a common good. So for smartphones, it was only like 5-6 years. Well, I tell you, for AI, it's going to be less. All right. So we hear about AI like since last year. Well, it's going to be common good from next year or so on. All the big ones are already deploying it heavily. Like Google, for example, they started out 2 years ago. Now, internally in Google, more than 3,000 projects depend on AI. More than 3,000 internally. All right? And it's going to be huge. So AI plus IoT plus cloud plus robotics, if you see what kind of money can be made with it, it's an extremely powerful information. So if you have the chance to study somehow AI or big data technologies as engineering or as free courses, please do so, because you will have to use it anyway. A sidetrack on big data is that you cannot underestimate the secondary use of your data because you don't know what tomorrow's questions will be. Anybody know that? It's an activity tracker, like I have one here, a jawbone. Now, what happened here? Anybody trying to guess what happened here in August 2014? Nobody? Right, in the middle of the night, there was an earthquake. A lot of people got up, and you see in Napa, that was where the most, what's it called? The epicentrum of the earthquake was, right? So this is an activity tracker. And all of a sudden, it's a distributed seismograph, right? So the guys from this activity tracker did not know that they could use their data for something else than just activity tracking, all right? So this might not be a very good example, but the other one is. Like, US government wanted to know from all the other countries in the world what the oil reserves were. Because that's valuable information, also for military, but also for economic reasons. What are the real oil reserves of all the other countries in the world? Okay? So there was a small company who came up with the following solution. What they did was they took NASA's free imagery, satellite imagery. They looked for big oil tankers in all these images, and then they tried to see all these oil tankers, and they have ceilings that go up and go down. So they try to find the shadow. So the more shadow you have in such a big oil tanker, the less oil is in there. All right? So they could calculate very accurately how many oil was there in a certain country. Now, this is secondary use of data, right? NASA did not take these images just to calculate the amount of oil in a certain land, right? Secondary use of data, very, very important. A second one I want to give you, and then I'm almost finished. Do not underestimate the power of the people themselves. Smart democracy pays off. First one, anyone knowing Duolingo? Yeah? Yeah, you do? All right. So it's a free tool to learn a language. Yeah? It's invented by, I think, Louis von Ahn, somebody from Guatemala. And what he found out is that in Guatemala, you can get a job much more easy if you know more than one language, right? So he was already rich, so he sold some other stuff, reCAPTCHA, to Google. So this is what he did for his people. So you think, okay, you learn a language. The business model behind this, the business model behind it is that the higher you go in this tool, and it's kind of a game, the more difficult the sentences become. Now, what he did was ask all the book vendors of the whole world, very big ones, look, you want to translate your book? Give the book to me. So what he did was just sentences and sentences and sentences, and then the more people the tool was used by, the more people, the better his translation of the books became, right? So now, automatically, he translates books by the power of the people, all right? Also, Google uses this, right? So I try this out, Quick Draw, and it's kind of a game. It's an AI machine of Google, so you have to draw a certain word as quick as possible, and then the machine guesses. This is what I tried. I guess my drawing is not too bad. And every time the machine got it right. Now, why would they do that? I told you about the unsupervised machine learning in the beginning already. So what these machine learning algorithms do, they try to find the right features to learn from. Like in audio files, the features could be timbre or pitch or whatever. But in an image, the features are color or what's it called? Color and forms. Sorry? Shape. Yeah, thanks. Shape. Yeah. They primarily learn from shapes, right? So now I give them the shapes, right? So the machine becomes much more knowledgeable without lots of examples, because the problem with machine learning today is that it needs lots and lots of examples to learn these features. Now, if we as humans give those features to these machines, they can learn much faster, much better, right? So being a researcher myself, I tried it on my kids, right? I have 3 kids, 17, 17, and 16. And well, you see there, it's a close call. The machine is already as good as my kids of my teenagers. Now, do we have to be afraid of big data and artificial intelligence? Don't panic. There will not be, in the near future, such a whole 9,000 like a machine that knows it all. Just to give you an example. This is us. This is everybody in the room. One brain, 2,000 million gigabyte of memory, 80 billion of neurons, but very small form factor, huh? Only 1,000 cube centimeter. Does lots of calculations, but uses not a lot of energy, huh? Only a small light bulb to do stuff. Now the one but biggest computer out there, a computer in China, about the same memory, about the same storage, but huge volume. Like, I think it's a room full of computers. About 3 times the calculation. So this thing is only 3 brains, but it costs, 5% of Doel. Doel 1, okay, Doel 1 is a nuclear power plant in Belgium. So 5% of a complete nuclear power plant it uses just to do the things of 3 brains. And it costs $390 million, all right? So lots. So to end, we as people, we use far less energy, much lesser form factor, and we are much cheaper than all these big machines. So you can call me bunkers, but I think in the next 10 years, we're still okay. We will work together with the AI machine, but they will not take us over. I'm pretty sure that an AI machine will win a Nobel Prize, though. This was a quote from last year's Sony Computer Science Lab CEO telling that. And if that's not true, you can call me bunkers too. Anyway, I think data is the new oil, and AI is the new rocket engine to your oil. The future is bright for AI and big data. Questions can be asked later. And I have to show you this last one because I always steal images. Thank you.
For foreigners who does not speak Russian, from now the session will start in Russian. Okay? Perfect. Who is next in this case?
Доброе утро, друзья. Good morning, friends. Now we are going to have my presentation and we'll start burning now here. So I'd like to talk to you and discuss with you some specific things. I'm not going to talk about some theories and research, but I'm going to talk about applications. How can we apply machine learning and big data to make money? My name is Evgeny Rosinsky. I am the technical director of IVI, but I also teach at Bauman Technical University on the team software development concepts. I will briefly discuss what I'm interested in, what data I like and what data myself and my team are analyzing, and then I'll show you some methods how you can extract money from people and do it legally, by the way. So IVI is the biggest legal video-on-demand service in Russia, with thousands of movies available, hundreds of thousands of requests a second, millions of active users, and those millions of active users generate hundreds of millions of events using our applications. So these are the data that we can use to analyze our audience. And since we have such data, a few years back we decided that the strategy for the company would be based on data, not on rumors or not on intuition, but on data. So let's move on. And we are present in all the platforms, starting with iOS and all the way to the strange platform of Xbox, which is not that popular. But who are our users? So our idea was to make sure that the service would be very popular, so that users can get relevant content. Almost all big companies use a very simple approach. You have a hypothesis, and then based on that hypothesis, you make some experiments. You analyze data, and then you change the product. Well, this can be both the user interface and the algorithm that is used for, say, the search results. It can be a dynamically generated user code and interface, etc. This is all called a product. So let's go around the circle and start with a hypothesis. Where can you get a hypothesis? You can steal a hypothesis, an idea from competitors. We see how our competitors and how the same companies do it to capture the audience, and we decided that we can simply steal the product or the idea. That's a tradition for a fast-growing market. Second opportunity would be pure luck. You know, a hypothesis, an idea can be born out of pure luck. Creativity is very important in a business, and only through pure luck can you get a product which would be to the liking of the audience. One day, our analysts would approach that and said that, guys, for some reason, The Fifth Element, a movie called The Fifth Element, became very popular, and people are paying to watch it. Why? It's a very old movie, and one of the guys said, you know, it was shown on TV yesterday, so there is a correlation between what people watch on regular TV, and then in 2 or 3 days they would come to the video on demand service and try to watch the movie again. Then intuition. My colleague actually described to you the artificial intelligence, but let us not forget about our natural intelligence, about our brains. I mean, there are geniuses, right? People who can really feel the audience, and this is something out of the domain of psychology, when people actually creating a product already know what the audience needs. So probably this is something that we also have to take into account. And the most important approach, the reason why we're here, is the work of an engineer with data. Engineers who mine for such hypotheses and try to somehow put together a very important things using bits and pieces of various information to put it together into a hypothesis. So let's see what we can do. In the online service business, you can test a hypothesis in 2 ways. There are online experiments where you use live audiences and you test or you take a laboratory rat and see what you can do. What would happen if you take away the Facebook from the users or do something else? And you'd see how the audience would behave. Another important thing would be offline experiments where you would create a model of your user and you use this model to test your ideas and the product impact. A hypothesis costs nothing, as a matter of fact, but the usage of this hypothesis, the application of it, would cost money. How would you bring it to the audience? Let's start with the online experiments. For online experiments or tests, you need 3 things. You need high-speed release management. You really need to roll out your idea into production to get the fastest feedback from this hypothesis. Then you need to know what is A/B testing, where you split the audience into several groups and you use different impacts on different groups of the audience, and then you compare what the audience did. Was there a change in the behavior? And this all culminates into analytics. You need to release fast, you need to be able to do the A/B tests, and then you can you also need to be able to analyze so that the resources that you spent on testing were not wasted. With offline testing, it is a more interesting and more difficult story. First, you need to come up with the user model, or come up with the criteria where you would test the validity and adequacy of your theory. And then, of course, you need to preserve the time and reserve some time for the testing. For the online testing, you need 2 or 3 engineers, but it would take 20, 30 developers and engineers to roll out and release the product. So a lot of people, and you have to synchronize the actions and time of such people. From writing up terms of reference all the way to putting them together to work. Also, for offline testing, you are not torturing your users. You basically offer them an already tested hypothesis. So offline tests would be the first barrier who would save the psyche and the health of your users. And of course, you reduce the cost of development and you use more efficiently your resources. So of course, you have to use statistics and look far into the future. Your first offline test would probably cost 2 or 3 times more than any online test. But after you have such a testing factory, an offline testing factory, then, of course, in future, you would cut down your costs for development. And also, for the offline testing, you should not forget that in addition to having some exact information and data, but probably there are also errors, not only in your data, but also in your model. So your model user may be quite different from the real users. So offline testing without online testing means nothing. So in any case, you will have to test your hypothesis on real users. Now, coming to the question of analytics, if you do the testing, you'll have to remember the mathematical statistics and statistical significance of experiments, whether your experiment is in line with the criteria and your expectations that you had before the test and that you wanted to test. So you have to verify your data. That's probably the most important and difficult question. We will be saying, okay, big data, so wonderful, blah, 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 but even before you come to this mathematical noodle, you need to verify such data. How would you trust data? Just imagine, you have dozens of applications sending millions of events, and hundreds and dozens of various developers are involved in the process. So on the way, there will be mistakes, since we all live in the internet and we work mostly with the HTTP protocol, which is not guaranteed to deliver information, especially statistics. Some event was lost, a router may fail, or something else happen. So the more data you have, the bigger would be the the smaller would be the probability of errors. But the biggest headache for a data science engineer would be to make sure that the data are valid and correct. You cannot trust blindly the validity of your data. You have to test it. Then, stability of results over a long period. For example, you test the survivability of users or the attrition rate of your users from your online service. And you have, I don't know, maybe the user would stay with your service for 6 months. Now imagine how would you do an online experiment over such a long period of time. So you have a product change. Now, what would you do? So do you have to wait 6 months until this tested user would go from your service? No, of course, I mean, you can use offline tests, but you will have hundreds and thousands of metrics that you will have to use. You will have to use triggers to see how data are being changed. Next big thing is that when you embark on this way of modeling, you have to also work with boundary conditions. To simplify the task, we fix certain parameters, and those parameters cannot be fixed. In the case of our service, say a big impact on the popularity of our content would be weather. So when there is, say, rain across Russia, we all get together in our company and we pray for the rain not to stop, because, you know, people just stay home and watch movies. About technologies, it really looks very similar to what the previous speaker told you. What do we use and why these things? A few years back, machine learning and big data became very popular as notions. So, for example, machine learning algorithms were available 20 or 30 years ago. The mathematical background is not something new which just appeared yesterday. We only are talking about some minor changes in the algorithms, but the capacity to compute became very high. Plus, we have a large community of various projects. So you can go to GitHub and you download a few libraries. They are free. And then you do the experiments. Quite easy to do. So we're actually focusing on the open source projects. And out of this whole zoo, we have only the column-based database from Hewlett-Packard. All the rest would be free. Of course, you have to use programming languages, Python, Go, and Java. That's what we use. Now, whoever would be interested about the technological stacks, I can probably discuss this face-to-face with you. Now, what did we manage to achieve? Using the approach based on data. The results are quite good. Back in 2014, we decided that we want to make a step without first doing an analysis. So we actually methodically were studying our users. So we came up with our recommendations and rules, which is the basis for all our service. And we also decided that we would be working with the paid audience, the paid users. If you see, before, we didn't have many people who were paying, so we made most of our money on advertising. And now, a few years after, the income that we get from the paid services, we have to go back. You see, this paid content share is now giving us more revenue than advertising. And this is not the limit, because we have hundreds of other new hypotheses to use. Now we have to probably line them up and do a lot of testing and experiments with those hypotheses. We can develop a business, and you can simply describe your strategy for the next year, because you have the data available. Such an approach actually gave us an opportunity to actually exceed even the popularity of YouTube in Russia. I mean, there is no paid content in YouTube, but in the first 6 months of this year, we managed to somehow exceed YouTube in such income. I think I'm done. Thank you, guys, for your attention. I would be happy to answer your questions.
Да, конечно.
Use the microphone, please. Shall I switch it on? Now let's try another microphone. Oh, sorry, the questions are in the end. We'll do that after the presentations. Okay, thank you. Hello, everybody. Can we put my presentation on screen? First, organizational matters. As the moderator has said, for the best questions after all the presentations, Acronis will present you with prizes. This is annual subscriptions to our product, and Acronis through Image 2017. So ask your questions after the presentations. The best will get prizes. Another request in Telegram channel. We have a poll. Please visit and answer the questions of the poll. And during this presentation, I'll explain why and how it works. My name is Nikolai. I'm director of academic programs in Acronis, and I'll tell you today how we use artificial intelligence and machine learning in Acronis. I'll share my vision of where this is moving, and the most important thing, you might be interested, how to become an expert in this area. Who are we? The company was formed in 2003 by graduates from the Moscow Physical-Technical University. Now we're world leader in the protection and storage of data. Our solutions being used by more than 5 million people in 150 countries of the world, and more than 500,000 companies, including small and medium companies and huge companies like Audi, Pfizer, and Sony. Why our products are so much in demand? We are a company working with the leading research institutes, and we're really for innovation. Our main office is in Moscow. We have more than 500 people there, of which a big proportion is PhDs and Masters of Science. We have also 6 universities with whom we cooperate: Bauman, Higher School of Economics, St. Petersburg Economic University, and the Nobles University, and others. Well, our partner relations are different. The Bauman Institute, we have 2 master's programs, one on computer science, associated with machine learning, and Higher School of Economics, we have our own laboratory, where we work together with the students of that university. And all these sources are being used to get highly qualified personnel. New knowledge and new ideas come from them as well. Well, within the context of this panel discussion, the big data, what big data is it new oil or is it waste processing? I'll imagine big data is new oil. Then we would handle safe storage, processing, and transportation of oil. Please raise your hand if you ever came across loss of data, like your PC fails, etc., etc. You're right. You are the 90% of people who lost data, who have this experience. It could be a simple bug in the operating system or problems with the hardware. In 2016, more serious threat came about ransomware. In the opinion of many specialists, 2016, that was a crucial point because total damage from such programs was more than $500 million. In 17, they say the problem is going to be even worse, and the world will lose $5 billion. Imagine the money. For a long time, one of the ways to fight ransomware was backing up. While the program would block access to data, you will use the backup from the cloud. But 17, the situation became worse. We witnessed two attacks. One was WannaCry. 100 countries of the world were affected, paralyzed. Huge amounts of companies, government institutions, and users, individual users, were also suffered. And the second was Petya virus and not Petya. This is a more sophisticated story. In addition to encoding data asking for ransom, well, in the development of that virus, they didn't think that the code for decoding was the right code. As a result, the companies paid, but they could not decipher the encoded things. To fight these threats, we decided we should develop new technologies. And we developed this Acronis Active Protection solution, the first such solution using machine learning tools. What did it give us? First of all, machine learning allowed identify the patterns in the behavior of infected systems and capture the status when the system is normal or when it is infected. The ransomware software is quite sophisticated right now. Before, they simply blocked their desktop and you couldn't do anything. But now, gradually, they start slowly encode and delete your documents, like you're writing a diploma paper. It's May. You want to submit it in June, yeah? And you try to open what you've done so far, and it's encoded. Just you get the message. Pay me this amount of money in Bitcoin, and I'll send you the code to decipher. And you're then thinking, what did I do wrong? And there are many answers what you could have done wrong. Now, let's see how our algorithm works. First, we collect information of how systems work in infected state and non-infected state. To identify the patterns. We will use the patterns to define whether a system is under attack or not. And if it's under attack, then we have to take action. What kind of action we can take? We can block. Our software can block any transactions with data like deleting, encoding, etc. And would ask your approval as user. It would ask a question from you whether it's okay and whether it was you that were doing this with your data. Not very many people at one point in time would start deleting gigabytes of information from their hard disk. Only if you purposefully clean the computer. You don't do it every day. What are the main advantages of using artificial intelligence? First, protection against really sophisticated attacks. Second, real-time protection. You don't need to click on check for viruses, it would do in our software would do it on background, checking on whether everything's okay with your data. And finally, this is a possibility to have better quality protection of data. Now, I've talked about what we're doing using artificial intelligence. Now, let's talk about the trends. What are the main ones? The first thing is, of course, robotics, autopilots, like humans, robots like humans. Have you seen the robot test pen in this exhibition? You haven't. It's a great robot. It can answer very interesting questions. This is Russian made. Next, all types of systems issuing recommendations like UEV. It is that story. They recommend movies, what's worth watching Friday night with your girlfriend, and this is like this. Using artificial intelligence applications are many, like the first speaker said. It's huge amount of various industries that can be used. What are the problems with artificial intelligence? Several. We came across ourselves and some social, like any innovation and artificial intelligence there's problem in interaction with people. A similar slide that was shown by one of the speakers. At the start of the development, each of the technologies confronted very many barriers. Like when the telephone was invented, telephone communications, the inventor, Bell, came to the biggest company at the time. He said, okay, I'll sell a patent for this technology for $100,000. Not that much money. They said, that's strange. Why would we need this? Okay, time passed. Whoever used the telegraph last time, they know how it looks like. We're using different telegram, right, or sending telegrams through a different system. Okay. And the main question, are we prepared to accept the technology? This is problem one, maybe growth in unemployment with the adoption of new technology, where whole professions will go into the past, and interaction between AI and humans. Remember the Terminator movie. We are afraid of such a future. What else? What kind of problem do we have? This is a problem associated with the thing how to regulate what's happening with AI. This is a story with Elon Musk and Mark Zuckerberg. They argue about whether to allow or not about allowing or not, but how to regulate AI. And technical issues, a simple term, junk in, junk out. You filled out your questionnaires. There was a question there. Identify yourself, your age, and best number from 1 to 100. Two of these questions, a question from 1 to 100 will give you no understanding of what is going to happen. That's no information. And that's the main idea down here, that data is not equal to information. The next problem is understanding the algorithms, how it works. Previous speaker told us about how to communicate with the algorithm correctly. You build the hypothesis, test it, analyze the results, and improve. Now, one of the most interesting slides, how to become a specialist in artificial intelligence. First, online courses. Raise your hand, please. Who did such courses? There are three biggest platforms, Udacity, ADX, and Coursera, online training. A lot of online courses, very good ones, which you can pass and get the necessary minimum background to start your journey to becoming a specialist. Then you have to go to master's program in computer science. This is one of the quickest growing areas, very popular in terms of science, very good for education. Many universities offer such courses, in particular Moscow Physical Technical Institute. We launched computer science program this year. Having passed this training, you will get the basics. And the most important thing, after you passed your training, you want to grow further in your profession, you need to select a company that really does AI, machine learning, using existing algorithms. Having come to such a company, near very skilled professionals, you will grow much quicker. This is it, the presentation. Thank you. I'd like to also announce this. Since 2018, we will launch a new training program in Acronis. There are questionnaires on the table. You can fill those out, and you can try to get to that program. Our HR does handles all this process. Now it's time for questions, I guess.
Just to add one more use case before we start with the questions. At the European Parliament, what happens is the first time when one document starts, we receive the document from the Commission. After, at the European Parliament, they translate, revise, and after, again, they validate. After this is the book out. When this book out happens, all these segments, because seems to be is good quality translation, all these segments are stored, and this is thematic index. That means that next time, when the Commission sends this segment to the Parliament, and it has 100% match of this segment, they are going to automatically obtain this information in all the languages. This is going to help the translator. Talking about artificial intelligence, it's true as well that the Parliament now wants to implement matching translation. So far, we are using it, but it doesn't start with 100% of match. It starts with 70% of match that obliges to the translator, both to the all linguistic units, to translate this or to check this, and it has to pass through the translation, revision, and validation. Okay, guys. Now let's start with the questions. Questions about big data, artificial intelligence. Boom. Okay. Over here.
Я вообще Евгению хотела задать вопрос.
My question is to Evgeny. I love watching movies, and sometimes I'm using illegal methods of downloading. And I use EV services as well. They are legal, of course. My simple question is this. You have monitoring, right? What is the audience? What is the audience? Which age group are your users most? And second, which movie genres are most popular in EV? In answering the first question, our audience, I would reply like this. At which time, which audience is the prevailing audience? Well, we can easily track in terms of content consumption who is before the screen. In the morning and until 6 p.m., it's children. They're watching animated cartoons and children's content. Children's movies, animations, etc. Starting at 6 p.m. Children continue to watch, but adults start watching as well. And until 11 p.m., it's roughly, and our peak hour is 11 p.m. And there are, yes, 11 is peak load. So since 2 years old, the age bracket from 2 until 60, 70, and that's the audience. And your second question was about genres, types of movies. That depends. Again, you can do these relations differently. You cannot compare free watching with paid movies. Well, more indicative, what people are ready to pay for, the second part. And these are new films and well-done films, quality films. And in free segment, there's a lot of correlation with what is shown on TV. This is a series and various types. And there's a tendency right now, since series is better quality than they were before. It's like a full feature film, and the emphasis of the audiences now from watching single titles to series, because these cinema studios started shooting very good quality series.
The question is more common than technical. My name is Victoria. I'm from Khakassia Republic, Russian Federation. I noticed that the more smart devices and technologies we get, the less people start to think by their own. So, don't people pay for their own degradation? What do you think? The question is to everyone. Thank you.
Push the button. It's a fair observation, but I think in the end, it's going to be merged. I think AI or robots will co-live with us, and we will give feedback to one another. We will learn from one another. On a philosophical point of view, I think that we have to rewrite the Human Rights Declaration, because also robotics or robots will have some kind of rights and will have, and of course the opposite of rights, they have to obey to some rules as well. I think we will get smarter in the end, but like tasks where we don't think a lot, we will just don't do them anymore. So very difficult calculations, we will not try to do them anymore because computers or machines can do it better. But maybe we get more time free to think more out of the box, maybe together with computers, to produce more fine art. Like, we will do other stuff that we're good at.
Отвечу вам на языке Хакасии, да?
No, I'll answer you in the language of Khakassia, maybe. And, you know, as a matter of fact, the question is very difficult on the one hand, but very simple on the other. Evolution would probably put everything in order. If we degrade, we'll probably disappear. Those who do not degrade would progress. Those who would not be about self-development and would only be consuming, in the end of the day, would be pushed out of jobs by some automated systems and machines. So society is self-regulated, and the finiteness of resources will push us this way or another. That's what I can see. My contribution, in the end of the day, a gadget is an instrument, a tool, and the way you use it, you would define whether it would help you or not. trivially. People can watch some video clips on YouTube. Others can go and watch some educational movies and video clips. If you want to self-develop, you do this. If you don't, then it's your free choice.
Ох, как много рук-то прям до вентилятора.
So many hands, we really see something going into our fans.
Oh, it is not okay. Now it is. Okay, hello everyone. I am Mladen from Serbia, and I'm new in this kind of technologies. I'm very interested in this kind of stuff, and I just want to know what is the best way to start learning big data and artificial intelligence technologies, and what kind of knowledge is necessary for beginner to start to learn.
Well, my colleague just told you in one of the last slides. First, online courses, follow kind of a master, and try stuff yourself. Okay, there's plenty of good universities out there. Mine, for example, you can come to Ghent University and follow my course. I have 70 people, 70 researchers doing top-notch research in artificial intelligence. On semantics, we are top 3 in the world. In artificial intelligence, maybe you know the Kaggle competition, which is a worldwide competition on AI problems with 500,000 participants, data scientists. My team won it 3 times the last 4 years. So.
Okay.
But first of all, before you will visit this university, you have to have the basic knowledge about computer science, basic knowledge about mathematics, about statistics, and about software development. Not software development, but software analysis. And it is the first step. And then you can think about the algorithm, etc., etc., etc.
True. So basic languages, Python and Java. If you know Python and Java, you can go a long way.
Okay, I don't know Python and Java, but I know C# and object-oriented concept. It is not difficult for me to change that technologies and to start to use
there
Java.
are a lot of framework on C#.
Lot of
Yeah, just visit Microsoft, and they have a lot of innovation about this kind of knowledge. Yeah.
Okay, thank you.
Да, я, может, тоже добавлю такой небольшой summary.
Probably a summary for you. First, what you need to do is you need to understand mathematics and the probability theory, like probability theory 101. That would be enough in terms of mathematics. In terms of programming and software development, you don't have any one universal language. People try different languages, but you probably need to learn Go or TensorFlow. You just, go through it. There are online courses, a good university, and the right job. That's what you need.
They should give the mic here in front because lots of questions.
У вас только один.
Здравствуйте, меня.
Good morning. My name is Alena. I work with technologies, and I actually heard many lectures and presentations here. We heard about competencies that need to be developed. So my question is, we saw some slides about technologies penetrating our life faster and faster. Robots in 5 years' time would probably be part of our life. And the question is probably also from other audience. Do you think it is already too late to study machine learning and AI? Because in 5 years' time, people would be graduating, but machines would be everywhere. So probably we need to think about other skills and competencies. This is a lottery. You have to forecast yourselves what is going to be popular in future. Today, it is already an industry. 5 years ago, it was a prerogative of research institutions and big companies. Today, it is already an industry, like programming before in the past and like many other disciplines in the past. So today, this is something which is significant and is attractive. Maybe you cannot expect any breakthroughs here, or major breakthroughs, but as a minimum, engineering knowledge and technical knowledge would be in high demand. So everything is changing very fast. 2 or 3 years and everything changes. So you have to train your brain in a way so that you can adapt to the fast-changing reality. So some basic training is required, and then probably you can change yourselves in any direction. Of course, you can create new algorithms or recommendations or rules, or you can use the existing ones. Of course, it is more interesting to do something from the scratch, but our society needs automation, and this would be in high demand. Both regular engineering skills and artificial intelligence. You can try it, and you won't lose. Well, I mean, the idea of any university is not to give you a ready-made set of knowledge, because when you graduate, your knowledge would probably be already a little bit outdated, however hard you study. So you have to study throughout your lives, and this is a well-tested method. The question is whether you should still try to catch this train which has already departed. As Evgeny mentioned, there are many sectors and areas in our life where we still need AI, and you need to have a basic set of skills, and then you can take pieces of puzzle and probably come up with a solution.
We miss one thing, so we're only at the start of AI. So knowledge workers will be hugely in demand. I think we will need millions of people doing knowledge work. But do we have to have millions of artificial intelligence engineers? Yes, but no. It's not only engineers we want. We also know there's the thing out about languages. So we probably need also lots of linguistics people. So not only engineers, but linguistics people to try to find out what the nitty-gritty details are in all the different languages. We need lots of prototyping experts, designers. How will we interact with all these new machines? So it's lots and lots of more things we have to know than just the AI algorithms. So it's also we have to kind of know how users interact with these machines. There's also social sciences, designers. You can learn everything, and you will be a knowledge worker. Not only AI and engineering.
Я еще добавлю, что на самом деле самое вкусное, как
The sexy thing is basically on the border between social sciences and economics and technologies. And having some basic knowledge in one of the areas, you can be rest assured that you will be in high demand.
Have a good question?
To any four of you, I just want to know, what is the impact or implication of blockchain on big data and AI and vice versa?
Кто хочет поговорить про блокчейн?
Blockchain is a good and a new technology, but I think it's a bit overhyped for the moment, right? AI is not overhyped, blockchain is. If you're talking about trust in the complete scheme of things, then it will be kind of a solution, but for the moment it's not that scalable. It's very slow, because you all these peer things. What you have to do, if you have the more how to call it, the more contracts or the more things come in this certain blockchain, certainly the one of Bitcoin, the more calculations have to be made. And it could be that for the moment you have to wait kind of maybe 30 or 40 minutes until something comes back. So it's a good idea, but real implementations out there need lots of more of rethinking, whereas AI is already more mature. So we will use it for something, but it's not the holy grail.
Ну, я соглашусь, да, с коллегой.
I would agree with my colleague that probably it is not correct to put these things on one level, because these are different technologies probably designed for different things. If you take, well, I mean, there is a lot of information and hype around blockchain, but before we marry the two things, I would probably wait and see when we have a lot of applications in blockchain. The story of blockchain, I mean, what is the interface between big data, blockchain, and AI? Probably the common thing there would be privacy. So socially speaking, these two technologies, this way or another, would have some impact on the privacy and confidentiality of our data. One technology protects it, the other one probably discloses it. So for industry, it is not yet clear how to apply blockchain. There are all kinds of, science fiction technologies, but both cryptocurrencies and blockchain, they have a lot of problems in interfacing with the governments. Let's wait and see when we have some real applications in big business, when such technologies would be tested for a year or two, and then we'll see how to couple them. Technologically speaking, this is a very difficult story, because blockchain has a lot of limitations. Most important one is the size of the block and the volume of information that you can put into the block. Big data is about terabytes. Blockchain is about a very limited amount of data there, because it affects speed and the computation capabilities. For example, we can use blockchain for additional verification of data. It is not that we keep all data in blockchain. In blockchain, you have hash data of the documents that were put into some storage. So if you have a document of 10 megabyte, the hash data for that document is only 1 kilobyte. It is in blockchain. If need be, we take it out of the blockchain. We compare it with the hashtag of the document in storage. If they match, fine, we work with the document. If not, then we tell the user, sorry, there are problems. There is no match. But conceptually, blockchain and big data are two probably different things.
Нет.
Вот, слышно, спасибо.
My name is Vitaly, I'm from Moscow, and I have a question, perhaps to the first speaker more. In the end, you were talking about some dangers of big data, and you gave the example that one of the most powerful computers is equal to 3 human brains. But 20, 30 years ago, a similar size computer would probably fit my telephone here. So we have a geometric progression in the growth of computational capacities. So, of course, people who know a lot about human can control a human, and with those who know about big data can control many more. Well, we don't have algorithms to probably process a lot of data about an individual person. Maybe in 20, 30 years' time, it would be your routine life. You can know a lot about every person. Although you can still not process certain data, but people are fighting for being able to do that. In Hollywood blockbusters, you always see the theme, who would own data, corporations or governments? So this is probably the red line of many, those ideas in Hollywood movies and books and etc. So what would you comment on that?
You're right. It's quite a long question. Anyway, about the data and who owns the data, I have a particular view on that. The thing now is that it's not the people or the companies who own the algorithms that are the most powerful ones. It's the ones who owns the data. Because nowadays AI, you need lots of data to become smart. And unfortunately, the ones that invest and have the most money have the best AI algorithms, have the best researchers, and also have the most data. So in my humble opinion, that's not a good thing. And if you look back in history, once there was a similar example. It was the most wealthy man ever on earth was a guy named Mr. Vanderbilt in the United States. It was late 1800, and he had a monopoly on both all the trains in America and all the oil petroleum thing. And then, there was the Sherman Act, who kind of divided these things into more manageable pieces, so such monopolies are not possible anymore. And I think we need such thing on the data as well. It's not good that a few companies like Facebook, Google, Apple, and then also Alibaba and Yandex and stuff like that own all the data. Now I'm working, or my team is together with Tim Berners-Lee of MIT, are working on a complete new revolution on how to perceive data yourself. So everything should be, you as an individual should be the owner of your data with personal data pods, and all the companies out there should kind of ask or pay for all the data. But for the moment, the internet is not scaled to that. So I think it's going to take us another decade to think like that. And maybe things have to come from bottom up, like from you, the youth, saying, look, it's not good that all the big companies just by thinking consent have all my data. And maybe we should use obfuscators so they don't automatically get all this data. If you use the right browsers or always browse anonymously, they don't get the data, but by default we don't do that. But it's a good question.
Next question up there, just behind.
Hello, my name is Nikita Kovalyov. I'm from Orel, Russia. My name is Nikita Kovalyov. I am from Orel, Russia. The first speaker mentioned that there is a supervised learning, supervised process of learning, the teaching of neural networks, right? So I don't know, maybe this is a common thing, but I simply don't understand. Is the supervisor always a human being, or other neural networks can teach other neural networks? And if so, how much time we have left before one military network will teach Skynet from Terminator?
True. Two things. For the moment, you need the AI algorithms to learn need lots of data, right? Now, in computer science, the next big thing is trying to have algorithms that don't need a lot of data. Like if a little kid, if you teach or show something 5 times, the kid knows what to do. Or you show 5 images of elephants, 5 images of cats, he knows the difference, right? Now, a computer at this moment in time probably needs 100,000 of images, right? So this is the first thing. So we work on algorithms that need much less data than the current algorithms. Okay, I wanted to say something else on your second question. I lost it. What was the question again?
Yes. My second question was about, is a supervisor always a human being? So can other neural networks teach other neural networks?
Yeah, that is possible. What the label data is like, okay, yeah, you need, okay, of all these images, at least somebody once has to say, look, this is a cat, this is a cat, this is a cat, but this is only labels, right? So the computer then only recognizes the labels, but it does not know what it is. So then there's another kind of artificial intelligence, semantics, right? Didn't talk on this one, where you model the knowledge of a certain problem domain and ontologies, and then let's say animals, and then you have a cat, and if semantically the computer knows what a cat is, instead of just a label, it says, a cat, the opposite is dog, a cat, it says meow, it has a fur, it has these kind of strange nose things, all right? So this is also helping to become, systems to become much smarter, much easier.
So the final part was about military networks that will teach Skynet. How much time have we left?
I don't like military stuff.
Okay, thanks.
Next question over there.
Yay, luckily, thank you. Let me speak in Russian. Меня зовут Татьяна Бражник.
My name is Tatiana Brashnik, and my question is this. Like many participants have shown, there's fear that the government would affect technology, both in AI and big data. My question is this. Are there any regulatory risks or fears or other things where the government can put brakes on the development of new technology and business in this respect? And generally, evolution, can government stop that? An interesting question. But competition helps there, in particular competition between states. If somebody regulates data storage industry, say, and the development of such technologies, then this country is going to be lagging behind other countries. This is what will make the countries change the legislation, is eternal competition. Nobody knows how to do it the right way, how to protect data properly. People will go from one extreme to another extreme, and iterationally. There's a method of mid-values. You go to one extreme, then take the middle, and you move to another point, and you do that eternally. The matter of regulation of any new industry works like this. Dichotomy, method of dividing by two. There are two extremes, whether to totally regulate and not regulate at all. But they will find the optimum. That's a very important social matter concerning our private personal data, our children, etc., etc. We don't want other people know everything about myself, like my sexual fantasies. Then the society will tell the government no. So the main objective is to not go into extremes. And iterationally, I'm sure we'll come to a model where we will pay some of our privacy for convenience. The debate is about this. What we've been talking about is more convenience when we get certain features without doing anything. Well, and we'll see what would be the price.
Question of the former one. Okay, I don't like military, but that's something. AI. Okay, there will be problems with AI, and everybody knows about it, and also the big ones are concerned about it. So there's an OpenAI, or there's an AI forum who really thinks openly on ethical and technical questions about AI, right? We can fool these algorithms for the moment, right? There's research to be done on the fairness of AI, because in America some AI algorithms cannot be used anymore, because if you're black and you live in a certain area, then automatically you could not be able to get some job, because there was a fairly high percentage that you were a drug dealer or something, and that's not correct, right? That's maybe in general correct, but not for one individual. Okay, and as I told you, there's a forum working on these things. And well, if you talk about AI and these algorithms, you have black box, gray box, and white box, right? Black box algorithms, there you cannot go back to see why the algorithm did what. But for certain use cases, maybe there should be a law on saying, look, if you use AI on a certain use case, it has to be white box. So we can always go back why the algorithm did something, all right? And probably there will be laws. And in Europe, we should take the forerunner role. Like the new thing, there's a new law on privacy, GDPR, right? That's a good thing. And maybe that's a way of Europe, again, becoming more kind of a forefront runner on more socially and ethically, because, well, for the moment, the money is mostly, on AI, is mostly made in US or in Far East. So we should invest more money on how to tackle these ethical and social things on AI.
Thank you. And may I add one short question to those?
Well, discussing this regulatory component, shall we consider social regulatory issues by elements like protection of private data, technical standardization, or all those elements together, like a separate law on AI, or a law on big data? So element by element, or combined thing, the law, what should be the regulation?
I would say, okay, there should be one big law, but with different aspects. And the domain experts should have an advisory role in this. There's okay, correct me if I'm wrong, but there's no European guy in Parliament that really knows the nitty-gritty details, probably of the real algorithms. Okay, so if you're in Parliament, well, let you help by domain experts. Let you help by professors in AI, or company leaders that vastly invest, or CTOs that vastly know about AI.
Да, я добавлю. В конечном итоге лучше, когда...
Let me add this. Better where a law specifically regulates very specific industry. Then that would be in a situation when this is gray, this is white, this is black. Better have one law that would explain everything, but it should not be in conflict with other laws. So let's do it the right thing, let's not do it the wrong thing, right? That's your answer, is that? On this one, let's ask a question.
Time we have. So I already talked with the panelists, and they are going to be eager to give you answers after we finish.
Может быть, последний вопрос. Вот молодой человек, он уже даже нарисовал картинку.
We ask one question from this guy who has already a picture drawn for the purpose of the question. Hello, but not into the microphone. Thank you so much. My name is Anton. I'm from Yaroslav State University, and I'm doing machine learning and recognition of objects. I have two questions. First is on the Amazon platform, Mechanical Turk. You can place data with hands there, or pens. We are come to a situation that, and you spoke about this, you can learn and build models using clusterization algorithms or confirmation learning. This service has been about for more than 10 years. Do you think it's going to continue? Is it going to be closed? Is there going to be demand for it? Because machines can teach machines right now. That's one. And second, unfortunately, we have very little time. One question, please, only. The other on the sidelines, please.
A question later on. Yeah, Mechanical Turk. I think it will keep existing because in my talk I said power to the people, right? So there will be always people who have to give feedback on the machines. Even if other machines learn other machines, there's always going to be a feedback loop of people, and Mechanical Turk will be definitely one.
Добрый день, Алексей.
Hello, I'm Alexei Solostsov from the Dniester Republic. $50 to 100 years ago, the information published in book was considered the final truth. Now, with the development of machine learning, new technologies, there are very many new generated useless and incorrect information. With the development of the new stages of AI, in this huge amount of information, a lot of information, but normal people, how can we distinguish between what is true and what is false in the internet? Well, I have this written in my book, and my answer is no, there is no way. Critical thinking, somebody says. Okay, thank you.
There's an answer.
Спасибо большое. Вы хотите ответить, да?
Want to answer?
So there's two things. One, there's the information bubble, right? So you have to get out of this information bubble, but if Facebook is an information bubble, you just have to know, right? And then on fake news, my team has a solution. Well, the solution is, in fact, but it's too early days. The solution is provenance metadata. If every data that comes into existence has automatically provenance metadata, then it's simple because you can always calculate the truth via this provenance metadata. The thing is that nowadays, when some information is created, there's not automatically provenance metadata with it. But it's only a matter of time.
Я бы хотел попросить моих коллег выбрать по одному вопросу, которым...
I'd like now to ask the colleagues to give awards to the best questions. Well, that girl, please.
Thank you so much for your questions. Eric, your turn.
The best question was the last question.
Thank you. Okay. Можете вручить.
From neighbor's question, it goes into ethics.
Ну, я подарю человеку из Сербии, который...
And guy from Serbia who asked how to become an expert in machine learning. He's not there. And select a different one. Terminator. I have two more. That young guy who drew that picture, you have to get a prize. But first we have to recognize him using machine intelligence. And Terminator as the most popular question for the audience. Friends, thank you so much. Let's thank the speakers also. Great thanks, a lot of thanks for presenting at the session, at the festival. And please be back at 11:30, back in this audience. We have a session devoted